that you'll learn. So today, we're not going to do a lot of math. We're going to do a lot of interpretation. 1.1 will be on the test. Okay? So, I was hoping in my last class I had another thing, but I'll save that for Tuesday. But all right, so 10.1 deals with what we call the language of hypothesis testing. Okay? All right. So let me give you just a simple example here, just to kind of get you going here. You and I we're betting on a game. Okay, we're betting on heads. Okay, heads and tails. So if we were to flip a coin 10 times, how many heads would you expect there to be? You would expect 5 heads, right? So if there were 6 heads, would you think I was cheating? You would? Okay, 6 heads, that's pretty normal, right? 7 heads. Well, you guys are a tough crowd today. Okay, 7 heads probably wouldn't think I was cheating, right? 8 heads? Maybe you'd start to wonder. 9 heads? Probably 10 heads. Now you're looking for the 2-sided coin, right? Now the question the idea behind hypothesis testing is, where do you decide when I'm cheating and when I'm not? Okay, would that be 7 heads? Would that be 8 heads? Would that be 9 heads? Okay, so that's what hypothesis testing is all about. How do you decide when a person is cheating? Okay, all right, so in order to do that, we're going to do hypothesis testing. And the first thing we're going to come up with what we call an H sub 0. Okay? This is what we refer to as the null hypothesis. Okay? So the null hypothesis is a mathematical statement. And we want to emphasize the math part of the statement that says there's no change, no effect, no difference, or in my case, I would say it's a fair coin. Okay? And I will also mention it's always about the parameter. And so when I'm talking about a math statement, what I mean is we're going to set some parameter equal to some value. Okay? And it's always going to be equals. Okay? You're always going to set it equal to something. Now, you can write the alternative as H1 or H sub A. I've seen it both ways in different books, and it doesn't really matter to me. That's what we refer to as the alternative hypothesis. Okay? So the alternative hypothesis is often stated in the problem, and it's a statement we are trying to prove. Okay? So now the one thing I just want to point out here, okay, a lot of times people get these two mixed up. Okay? The null hypothesis is always a statement of no change, no difference, no effect, fair coin, Okay, so in the example I gave you, you may not trust me. You may think I'm cheating. That's never the null hypothesis, never. The null hypothesis is always I'm not cheating. Okay? You may think I'm cheating, that's your alternative hypothesis. Okay, that's the statement you're trying to prove. Okay? All right, so the reason why these two things are important, and this is what I'm going to really emphasize, is finding the null and the alternative hypothesis, is because we can have a one or a two-tailed test. Okay? So a one-tailed test, your alternative is going to be less than, greater than. With the two-tailed test, you'll say simply not equal to. Okay? That's going to play a bigger role in, I was going to say tomorrow's lecture, but tomorrow's review, next week's lecture. Okay? So what I'd like to do is I'd like to do some examples here where I ask you to come up with a mathematical statement of a null and an alternative hypothesis. Okay? So let's say that a pharmaceutical company makes a new antibiotic for children. Other antibiotics show 2% of children have a side effect of headache. FDA wants to know if new antibiotic has more than 2% headaches. Okay? So right now I'm only concerned about finding your null and your alternative hypothesis, so I'm not going to give you any more information. But I'd like you to come up with the null and the alternative hypothesis. Okay? Daniel, I knew, was raring to go on this. Okay? So remind me, what does null hypothesis mean?
It's a math statement that says there's no change, no effect, or no difference.
No change, no effect, or no difference. So what does no change, no effect, or no difference mean in this?
Would it mean that the new antibiotic has the same percentage of headaches as the other ones?
Okay, so conceptually you're exactly right. The new antibiotic has the same number of headaches as the other stuff. Okay? Now conceptually you're correct, but that's not a math statement. Math statement has to have an equals in it. Okay? So something's going to equal something. So how do you convert what you just said to a math statement?
Could you say like 2% of, or 2%
So
children
something's
have
going to
headaches?
equal 2%, right?
Yeah.
Okay.
2% equals
So, and I'm going to write that as a decimal 0.02. 2% is 0.02. Okay, so a lot of people just stop there and they go, that's good enough. No, it's not good enough. This is where I get really picky, and I want you to pick the correct letter. So what letter should you pick? And oh, by the way, it deals with the parameter. Parameter is going to be a key word in here. What's the difference between, so we talked about that clear back in chapter 1. Parameter and statistic, what's the difference? Parameters for the population and statistics for the sample. Okay? So I need a parameter here. What's a letter that I would use for a parameter?
C, children.
C for children. Okay, we don't pick C for children. Okay, what are some parameters that we do pick in statistics? P would be one. What's another one? P hat. Is P hat a parameter? P hat is a statistic. Okay. What are some other ones? What'd you say? N is our sample size.
Would Q be one?
Q potentially. I'll put Q in there. I don't use Q very often though. In fact, never. But Q could be considered a parameter. What do I use for mean?
Mu.
Mu.
Okay, I was gonna say that.
Would I use X bar?
Yes.
X bar is a statistic, right? So it's down here.
That's the one.
Any others? Sigma, that would be a parameter. What would be the statistic? S. Okay, so you get some choices there, Daniel. Which of those letters should you use? Mu? Why did you pick mu?
Because it's, I mean, it's like an average.
So it's a mean, but when we're talking about percentages, percentages are portions, so we use P instead. Okay? Now, functionally, a mean and a proportion are analogous, but I get really picky on this stuff, and since it's percentage here, I'm going to use a P instead of a mu. Okay? All right, so Ms. Schunicke, what's the alternative hypothesis?
Well, they're wanting to know if a new antibiotic has more than 2% of headaches, so it would be, does the statement, so the new antibiotic has more than 2% of headaches.
So greater than 2%, but you didn't convert that to a math
Oh,
statement.
that one has to be one too?
That one has to be one too.
Okay, then,
What's the P one?
I don't know what to use as the, maybe P?
Maybe P?
Yeah,
Once you
sounds
pick a letter,
good.
stick with it. Okay? So yeah, they're both gonna be, your alternative and your null hypothesis are both gonna be based on the same parameter. Okay, so pick a letter and stick with it. Okay, pick the right letter and stick with it, it will even be better. But they should be the same. All right, let's do another one. How about, here's another example here. The blue book value of a 3-year-old Chevy Corvette is $37,500. Grant wants to know if the price is different in Miami.
Mu is not equal to 37.
U is not equal to 37,500. Okay, so very good. This didn't give us any indication if it was higher or lower. We don't know. Anybody know what the prices of cars are? They more or less in Miami? Okay. All right, so very good. So now, Catherine, is this a one or a two-tailed test?
That would be 2.
That's going to be two-tailed. And this one is a one-tailed. Okay, does that make sense? Okay, so this is where I get really, doesn't make sense? No?
I just don't get it what is the total for?
What's what for?
Like, what makes it 1 or 2 total?
What makes it one or two-tailed?
Not equal
Did
to.
you use a not equal, or did you use a greater or a less than? Okay? All right. How about alternative here. The standard deviation of a 64-ounce bottle of detergent is 0.23 ounces. Company purchases new machine and wants to know if the new machine has less variability. Okay. Find the null and the alternative hypothesis. So I'm thinking N2 wants to do this.
So with the null hypothesis,
Yeah, what does null hypothesis mean? No change, no difference, right? Okay, so what does no change and no difference mean in this case?
So we have standard deviation.
Standard deviation, what letter do I pick for that?
The
Sigma.
sigma.
Is that what it is?
Yeah.
Yes, sigma
Is
equals
point
0.23. And the alternative is, oh, we're gonna pick on Katie. The alternative is,
Sorry, I can't see what it says.
okay, standard deviation is 64 ounces. Of a 64-ounce bottle is 0.23 ounces. Company purchases a new machine and wants to know if the new machine has less variability. So your alternative hypothesis would be,
Sigma. It would be not equal to zero. We don't know. Or is, oh,
less variability, less than
0.2.
0.23. Is that a one or a two-tailed test?
One.
One-tailed test because
U is greater than.
it is greater than or less than.
Or less than.
Yeah. So this was a less than, this was a greater than. So that's a one-tailed test. That's a not equal, so it's a two-tailed test. Okay, so that's going to make more sense next week when we start really getting into the hypothesis test. But yeah, I just want to make sure you know that. Okay, so now, I told you I was going to introduce a new A word. Okay. So let's go back again for the example here. Now, remember I was flipping the coin. I was betting Cassidy. I almost called you Chantel. I was betting Cassidy on the heads and tails. Okay. Now the question is, so she's trying to accuse me of cheating. Okay. Now there's two mistakes that she could make. She could accuse me of cheating when I wasn't cheating, right? So let's say there were I got 9 heads in a row and then I got a tail. Okay? Now that would seem like pretty good evidence that I was cheating, right? But if you were to flip a coin 1,000 times, do you think you could get 9 heads in a row?
Yes.
Yeah, so it could happen. Now it seems strange only doing it with 10 flips, but 1,000 flips it could happen. Okay, so there's two types of errors you can make. You can make a type 1 error, or you could make a type 2 error. Okay? Now the other error that Cassidy could make is, let's say we only got 6 out of 10 heads. So she would say, you know what, there's not enough evidence that you're cheating, but maybe I put a little piece of tape on the coin, so I was cheating. So she would say I wasn't cheating when I really was. So she could make what we would call a type 2 error. Okay? So conceptually what the idea here is, the type 1 error is we reject the null hypothesis when the alternative was true. Okay. Put this down a little bit. The type 2 error says we do not reject the null when we should have. Okay? Now, we refer to these two types of errors. This one we refer to as the Greek letter alpha, and the type 2 error we refer to as the Greek letter beta. Looks like an A and a B, kind of. Okay? All right, so those are the two types of errors we could make. Which is the better error to make? Okay? So let's do an example. Let's go back to this pharmaceutical company, trying to determine if their antibiotic is safe. So the null hypothesis is, yes, it's safe. It only has 2% of headaches. So in the case of this, we're going back to this problem here, okay? In the case of here, the type 1 error says we reject the null, which in this case means we think the alternative is true. We think that it has more than 2% headaches when it is actually safe. Okay? So we think it has more headaches. So the other thing that I want to mention here, when we're talking about this, we always reject the null, or we do not reject the null. Okay? We never accept. Okay? And I mean we never. Okay? I'm referring to that as the new A word. That's a new swear word in my class. You never use the A word. Okay? And here's why. Because Cassidy just accused me of cheating and I wasn't cheating. Okay? So the reality is, when we're doing a hypothesis test, there's always two different kinds of errors we can make. And because statisticians are really anal, they never want to accept that they're going to reject the null or they're going to not reject the null. Okay? So we never use the A word. I won't say never, but you've got to have really super strong evidence, and we usually don't have super strong evidence. Okay? All right. So going back to here, the type 1 error, since we rejected the null, we said that more patients get more than 2% headaches when, in fact, it really was safe. So as a company, I'm not going to put an antibiotic out on the market, and I'm not going to make any money. That's not a good error to make, right? I lose money. But let's talk about what is the type 2 error. Type 2 error says I do not reject the null, okay? Meaning I think it is safe when really greater than 2% gets headaches, meaning it's unsafe. Okay? So the good thing about it is I make money, but then I get all this bad publicity for getting sued because everybody's getting a headache. So would you rather not make money and not get sued, or would you rather make money and then get sued? What's the better error there? What'd you say? Yeah, the type 1 is the better error, okay? It's the more conservative error. So typically, that's the error we're more concerned about. We'd rather be conservative, we reject something that was safe, than not reject something that wasn't safe. So typically, that's the better error to make, is the type 1 error. And so that's the one that I'm going to concentrate mostly on for the rest of the class. Okay? We will talk a little bit more about type 2. So as far as the homework goes, the homework is you're going to have to pick out the null and the alternative hypothesis, and then you're going to have to distinguish between the type 1 and the type 2 error. Okay? about it. I was gonna cover some more stuff, but I'll save that for next time. The one thing that I do wanna say, so this will be on the quiz tomorrow, it'll be on the test. Well, tomorrow or Wednesday, so you can take the computer part of the test tomorrow if you would like. The written part will be Wednesday, so you can take the computer part either tomorrow or Wednesday. The written part will definitely be Wednesday, and then Thursday, no class. I will miss you all, but I will be glad that I'm having a day off and I can sleep in. Okay? I can sleep in and correct your test. So while you guys are enjoying your fall break, just remember I'll be slaving away correcting